Alright, so we're doing a little bit of kitchen table electronics here. Here's the speedometer. Down on the floor is a 12 volt unregulated power supply. To account for that are all these little lights here, which basically just apply a few watts of load to the power supply to keep it from floating too high. They pull it down to right around 14 volts. And then out of the power supply, we power the plus and minus terminals on the speedometer, and then we also have the transistor back here. It's an NPN transistor, and basically the emitter goes to ground, the collector goes to the sensor terminal on the speedometer here. And basically how an NPN transistor works is when current flows from the base, which is the third terminal, from the base to the emitter, and in this case the emitter is ground, then it allows an even larger sum of current to flow from the collector to ground. And the pin, that is the sensor pin on the speedometer, floats at about 5 volts and wants to be pulled to ground in order to receive the pulse. The rough equivalent is 100 pulses per second equals 60 miles an hour. So we need to send an awful lot of pulses to this. So how we're accomplishing that is in the transistor, feeding the base of the transistor, we have this RCA, set of RCA cables over here, which come from the headphone out of my iPad. And basically one of them we're just using to ground. It's important to ground the sleeve of one of the cables so that we ground the iPad's audio driver to the same ground of the bench here. And then I'm taking the tip of one of these, which is basically the positive or hot audio signal, which will actually go both high and low, and that is what drives the base of the transistor. So what happens is a very small amount of current will go from the audio driver, from the tip there, through from the base to the emitter to ground, which will, when that occurs, allows a very large amount of current, basically opens the door all the way or saturates the transistor to allow current to go from the collector, which is hooked to the sensor port on the speedometer, which floats at 5 volts, and when the collector allows current to flow to the emitter, it then pulls that to ground and emulates the sensor coming out of the transmission. So the reason I'm driving this from the iPad with the audio is because on the iPad I have a generator, an application that is a sine wave generator. So instead of playing music or noise, it's just going to play pure sine waves. And actually what's better yet is it has a mode for square wave, which is exactly what we want, because we just want to saturate the transistor to send the pulse and then desaturate it to not send the pulse, to emulate that sensor. And we need to do it, like I said, 60 miles an hour is, I'll attach the formula as well, but 60 miles an hour is roughly 100 pulses a second. So we need to do about 100 hertz sine wave, and that sine wave will cause the output of the RCA cable on the center conductor to go high and low by about a volt, 100 times a second. The low we don't care about. The low doesn't do anything for us, but the high is what flows current from the base of the transistor to the emitter to ground, and thus allows current to flow from the collector, which is the signal pulse of the pulse connector of the speedometer, down to ground. So enough about that. Here is the iPad app. So I think we can see this here. So basically, the iPad app has a pretty simple interface. We want to do a very low frequency. Anything higher than that will be way higher than we're expecting. So right now I have these little octave buttons here. I'm going to crank it down to 80 hertz, 80 cycles a second. And up here at the top there is sine wave mode and square wave mode. And I'm actually going to go into square wave. The truth is sine works just as well, but square wave makes sure we're fully saturating and unsaturating that transistor. And then we just flip the switch, and so we can see 80 pulses is giving us about 40 miles an hour on the speedometer there. I'm just going to crank it up an octave, which will take me to 160 pulses, and there's 90 miles an hour. and I'll go up to 320, which pegs it out at 180 there. It's a little much. And so yeah, now I'm going to let this run for a while and see if my problem of the intermittent operation has to do with the speedometer or the sensor. If you do decide to do this, please be careful. You want to be probably much more organized with your wiring than I am, to be careful that none of the plus 12 volt signals end up in the wrong spots on the transistors, on the transistor, or on the signal pulse connection on the speedometer or on your RCA cables, because all of those could lead to bad things. So there you have it.